Alright. The inequality's back. Okay, I guess we have an inequality on the list for today. Gotta stay really. It's been a long week. Today's stream might not be very long because I'm like totally dead. But we'll see. I mean, if the problems are good, the stream will go longer, so send good problems. Also, because I haven't done Ibero 6 yet. Given that I went on a rampage on the Ibero problems recently, maybe I should knock that one out. But yeah, it's been a long week because, oh god, that looks so hard. You see my grading's going okay. It's going pretty smooth. It feels like things are sort of moving by themselves now and I don't need to watch it. The headache for me now is TSTST grading is tomorrow, so I need to like wake up and drag myself to campus and print out several hundred sheets of student papers. Yeah. The other thing was this week was I had my qualifying exams. So I spent a large part of the week like frantically trying to study, which turned out to be irrelevant because apparently they're not kidding when they say everyone just passes. No matter how badly the exam goes. (2020 ISLG4). I feel like that's probably in my system. Yeah, sorry. I'm spoiled. For mob reasons. Yeah. Literally. I'm so glad I never have to take an exam in my life ever again. Maybe. I might jinx myself saying that. But... Continue? Oh, right. I said I was going to try that again. Oh, I have no idea what I'm doing on that problem, is the thing. We'll put it on the poll. Yeah, I'll put it on, but I think if we do it, it'll mostly be me staring off into space. Unless I suddenly get struck with inspiration, which has happened, maybe, before. Okay, we're at 7. That is a thing that can happen. I'll wait a couple minutes for any more stragglers to submit there. Oh, I'm so sleepy. Oh my gosh. Alright, cool. It's 20:06, so anyone who's late is not my problem. Submit your votes. Yeah. But see, if you're a subscriber, your vote counts more. Because you sponsor the stream. Speaking of which, I don't remember the last time I got Twitch payout. I wonder how that's doing. I don't advertise Twitch Prime on your stream enough. Okay, actually, it's called Prime Gaming now. Alright, we'll be back after this quick advertisement. So, oh shoot, I need to hide the whole browser. Alright everyone, I'm here to tell you about this thing called Prime Gaming, where if you have Amazon Prime, you can... Actually, I don't know how it works. If you're present on Amazon Prime or something, they can give you free money every month. Yeah, that's basically it. So, yes, if you have Prime, give me free money. Thanks, that's all. Alright. That was not rehearsed, so, it probably did not work very well. Yeah. I think I know how I'd want to do it, but it's also, there's another streamer called Winter who's like much bigger than me who streams StarCraft and does really good advertisements. Unfortunately, I think it's like out of my capabilities. This is like way better than anything I could. I don't know. Maybe if I watch enough, I will figure out how he does it. Oh, the blocks is winning. Alright, cool. I kind of want to do the inequality. You know what? I want to do the trash inequality. Or comedic value, and then we can do the blocks. I'm hoping this means I solve the inequality, because if not, I'm going to be mega sad. Mostly because I have a feeling the 1x2x4 blocks problem might take me a while. It doesn't look like the kind of thing I'm going to solve quickly. It's not a dictatorship. I only have 3 votes, like a 3-to-1 vote ratio compared to you viewers. If you had all managed to just collude, it would have been fine. Oh, mostly because I'm curious, like, what the heck this is. Also, it's strict. Okay, Vedula, is this another original proposal? Why isn't there approval voting? I don't know. Alright. And then even ended with autocracy. No, it's only a 3-to-1 vote. You make it sound like I have an infinity weight vote. I don't. There are like 7 other votes in there. I'm starting to regret my choices, but it's okay. Right, but the point is like 3 is small. Like it's a dictatorship if the it's a dictatorship if the ratio of votes the dictator holds is greater than a half, because that means like no matter what the plebeians do, the dictator's vote wins. But if the dictator is only like a third, you know, that's not a dictatorship. It's just like I don't know what it's called in that place. Well, it's called Twitch voting, is what it is. All right. Welcome back, everyone. So today we have a 3-variable not symmetric inequality where I don't know, you want to show this thing is true for ABC positive reals, I guess. What the heck are these constants? So 2, 1, 5. If I let a equals 1 and c equals 3, and b equals 2, will that do something? The thing is, the inequality is actually strict, which really bothers me if there's no equality case. But 1, 2, 3 seems like it gives numbers, so oh, no, that's not good. C plus A is fine. Do I want like 1, 3, 3 or something? I love being game master, you know? I hate taking orders. 48 over C plus A. So yeah, I feel like A wants to be 1 and C wants to be 3, like extremely so. So 3 plus 5 over B squared, 16 B plus 1 squared plus 24 B plus 3 squared. Oh shoot. I just want to figure out where these constants are coming from. So is there a value of b for which these things are like kind of close? The 24 is pretty bad because there's not that many squares that divide 24. 12. Yeah, I take like 3. How close is it? 7 plus 5 ninths against 4 plus... That's pretty far off, actually. What the heck are the constants? Okay, unrelatedly though, okay, I really should know what this is, but I actually don't remember off my head. 1 over x squared is a convex function. So this inequality is true, and in fact, weighted combinations of this are true. So... probably I'm getting baited really hard, and I'm supposed to just... Because it feels like it's so loose that I should be able to just find some weighted combinations and kill it. What's the effective constant here, 8? Let's do this just generate alpha and beta. Okay, so... Okay, so this inequality is true by E.G. Jensen or power mean or whatever you want to call it. Should be a square on the bottom. Yeah, I don't think it's even close to has an equality case. So I think probably we're just getting trolled and like this is just something like... like some really stupid, like you put together some combinations and pray. Stop! Echo, stop! I hope I don't get a copyright thing for that. That's Spotify. Yeah, so I don't think this is a near equality case. This is probably just like something of the shape. Repeatedly apply something, and then like the constants are just picked however. So this is the generic situation, and we would like to pick some. So 2 over a squared plus 2 over b squared is at least 16 over a plus b squared, but that uses up all the a squareds, so I don't want to really do that. Thank you, ML123456 for 17 months. Maybe the advertisement worked. If c goes to infinity, is this true? Wait, no, I'm actually not sure this is even true. It's like 2x plus 5. Hold up, what? If x... Oh, I guess it's barely true if c is infinite. Okay, fine. But... Oh, yuck. Ew. Okay, so I don't want to use it this way. That's a fully general version of this I can do. If I put some weight on... Oh my god. Okay, I have to modify this. This as written is not going to cut it. Okay, so we're going to imagine a generic situation where I have 1 times alpha x squared and then beta y squared here. And I want to bound this from below. But I want to force the weights to be... If I straight use Jensen, it's like alpha x plus beta y, which is not what I want. I want like something that's uniform. Okay, so the claim is following inequality is always true. Beta plus alpha is at least alpha plus beta divided by the weighted average. That's going to probably give us the cubes that are showing up everywhere. So this is alpha beta x plus y. Okay, so that means this is equal to Jesus Christ. Alpha plus beta cubed times 1 over x plus y squared, and this is like over alpha beta alpha squared beta squared or something ridiculous like that. Yeah. Oh, b goes to 0 gives you equality? Wait, it does? Is c equals 1 going to be workable? I don't feel like I want to go down that road yet. Or I want to like try... I feel like it should be like some dumb combination. I just feel like the inequality sucks, and then some dumb combination of this will like be bigger than the corresponding gunk on the right. I just don't know exactly what weights I want. But okay, so what we're gonna do is I'm gonna then write this in terms of constants r and u and v or something. So let u equals beta alpha minus 2, v equals alpha beta to the minus 2. So then right, so I'm postponing. I'm not trying to just guess the thing because I don't think I guess it correctly. But I think that I should be able to just like blow it up. Maybe we'll find out. Okay, how do? Oh Jesus Christ! So alpha equals u squared v is alpha to the minus 3. Meaning alpha equals u to the minus 2/3 v to the minus 1/3. So the weight in front of here is u to the minus 2/3 v to the 1 minus 1/3 plus u to the minus 1/3 v to the minus 2/3. Oh, okay, Jesus Christ. Divided by like something. Times u squared v squared. So this whole thing is cubed, and then it's times u squared v squared. I really hope I'm not screwing up the arithmetic here, because otherwise that's gonna hurt. This is alpha plus beta cubed, and then so I want to factor out like u squared v squared is actually quite Why do the degrees feel so off? Hang on, what? This is like degree... I don't know. Thank you, Conchella92 for the follow. I just pushed these in, right? And then it's u to the 2/3, v to the 2/3. Ah, beautiful. So after that whole song and dance, I realized I was probably being stupid and I should have just used holder, but okay, here we are. So this is sort of the most... Yeah, this is definitely just holder. Shoot. This is the most general shape of bound that you can use here. And I feel like this is going in the right way because like these constants have factors of 8 in them that are very conspicuous, among other things. So now I want to like split the 2 and whatever up. This is not gonna go well. Yeah. Okay, so who picked these constants and why are they so bad? Okay, I'm just gonna guess a few constants and see what happens. Actually, yeah, I feel like there's not enough standing in the way and I should just be able to run it over. Unless there's something I'm not catching, but something like this should just work. Maybe? So 1 plus cube root of 2 is that? How big is that? Is that bigger than 16? Maybe it will help me if I expand this. U plus V plus 3 cube U. What's 1 and 2 here? I just picked random weights that looked like they might work. I don't know. I don't actually know if they work. They probably don't actually. That seems too small. But it's just I don't want to use up all of. I don't want to put 2 over a squared here because I can't use up the entire a. Like, sort of, if you want a and b to be equal, it's like 2 and 2, and that's like not what I want to do here. Jesus Christ. Unfortunately, I don't know how big cuboids are. One and like greater than 3.51. Alright, thank you for doing that calculation for me because I didn't want to do it. 1 4. That might be too much. Maybe I should just solve the system. Don't want to do that. Okay, let's see if this is desperation. Okay, so 5 minus s, 45 minus t, 2 minus r. Okay, s, t, 45 minus t, 2 minus r. So, in other words, I want some RST such that I didn't mean to put a caret there. So this should be at least 2 cube root 2. Cube root 6. That's what we're looking at. Okay, so I don't know how the heck I'm supposed to verify. Wait. Okay, not quite. I almost thought I could take like t equals 42. This barely fails, I think. We're all crazy. But it doesn't fail by that much. It's like cube root of 42 is is such a pain. I was really hoping it would just be this. So I need a little more room. I need to nudge T a little bit bigger. Oh, Jesus. This is pain. There's got to be a solution, right? Because I feel like this is so close that I don't believe that this could not work or something. Yeah, cube root 42, that's some cube. Yeah, so I want to nudge R a little bit. I just think about like what is the way to do this that won't require me to like take out a calculator, because I don't know. This is supposed to be. This is cube root 48. This is cube root. Make shades, yeah. that might be the play. Tell Twitch chat to do it. 16, 24, 48. I just don't know how big cube roots are, just broadly speaking. Why you do this to me? Okay, alright, here's what we're gonna do, alright? This is called desperation. R is, I just gotta guess some rent, try to guess. 2 times, so we need to amplify it by something that's kind of small. So I'm gonna pick 0.9 cubed, so that the calculation is not terrible. And then, so this means 5 minus s equals 1.1 times cube root 3 over 2 cubed, so okay, that is 0.729 is 1.458. Oh, that's actually quite a bit smaller than I thought. That might be too small. 5 minus s is supposed to be that. This ain't good. Shoot. I want it so that it's like a multiple of cube root. Wait, why was it so clean? It was because it was. Hang on, what? No, I'm stupid. I just can't. Okay, never mind. Here, 5 minus s is okay. S equals 5 minus that. There, that's what I wanted. So 5 minus 2.662 equals 2.338. Right? Okay, and then T is 45 minus S, the cube root of S. So this is the part that we might have to bend. Crap. So the problem is, because this doesn't happen to be like cube root 3 exactly, I might be in some trouble. is 45. Okay, we'll just deal with it. 45 minus 24. So far everything I've written is exact. It's not an estimate, but I think I probably, without cheating, I probably can't estimate the other part. So there's a. I probably need to estimate the other part. So 3 times cube root 24 squared plus 3 cube root 24 times 2.338 squared. Alright, did I get the signs right? This is minus 3 square here times that. Wait, hang on. No, something's wrong. S is... Sorry, S is the 5... Wait, what? Wait, this feels really big. Really? Okay, whatever. We're just gonna deal with it. All right. Multiplication is a thing that we can do because we're smart people. 23.338, and then there's like some term here, so I'm gonna expand the insides. So 576 times 2.338 is 10, 50, 50, 90, 14, 21. Oh Jesus, I'm old. 1296688. I flipped the sign with the cube roots. Oh! Yes. Oh, okay. That looks much better. I was like, this is not going the way I wanted to. It's like not in our favor. Sorry, this is 1346688. And then there's a small square here. I don't want to square that thing, so I'm just gonna bound it above by like 2.434. I'll just do 4, whatever. I don't think we'll need to optimize it past that. So 576 times 24 is 13.824. Wait, so really? 138.24. Okay, so now let's bound this by dumb crap. So this thing is, let's see, this is like about 11. Wait, so this is at least like 50, so this is at least 33. This thing is about, it's a little more than 5. So this is probably less than 16 thirds. This is probably less than 16, right? 27 times... Okay. So this is greater than 23.338 plus 16, or minus 16. And then, I hope I'm not dropping too much precision. That's pretty good though. That's pretty good though. That's pretty close to 45. Oh, I needed that precise. Really? It's like t cube root. Plus 2 minus r cube root. All right. Let's find out. All right. Moment of truth. So, cube root of 39.338 plus 2 minus r is 0.542. And we want this to be greater than cube root of 48. How do you even do that? How about I multiply both sides by 1,000 and cube root of 39338 plus cube root of 542. It wants to be greater than cube root of 48,000. Alright? And we're just gonna look for integer cubes that are near this. No calculator challenge. Okay, so what is a cube root? Cube root of 39338 is bigger than like... Okay, so 20 cubed is 8,000, 30 cubed is 27,000. 27,000. 40 cubed is 60, so... Actually, let me just deal with the decimals because it's a little more intuitive, I think, that way. .5. Maybe? Okay, so it's bigger than 3.5. Cube root of 0.542 is just greater than 0.8. And cube root of 48 is this less than 4.3. So it's 4.3 cubed is 18.49 times 4.3. Wait, that's actually quite generous. Did I screw up? I feel like it shouldn't be this close. Sorry, this is... What am I talking about? Wait, let me double check that I didn't screw up the 3.5. 3.5 is wrong. Yeah, 3.4 I think it is. Okay, let me actually explicitly compute 3.4. 11.56 times 3.4 is 39.304. Okay, that's like extremely close to 3.4. So then we should be fine here, right? Because we're so close. 4.2 cubed, 1764 times 4.2, 74. Yeah, this is way bigger. Okay, done by hand. Cube root 48 is less than 4. Oh, good point. I didn't even bother. I'm just like... Okay, that's fair. I didn't optimize that part because I'm trying to do as few optimizations as I can. But okay, I guess it's pretty close. Or it's not close, so I didn't have to try that hard. What? Why would you do that? So solution squeezes 4 over AB. Plus 12 over CA. Wait. So you AMGM and then what? You use... Oh, that's so bad. Wait, but I feel like in that case, this method should have picked up those weights. 1, 1. Four, 9, 136. Wait, now I'm confused because I thought we checked that RST like 1 didn't cut it. Is my... There's no way the round I have is weaker than the composed thing, right? So in your notation, you were saying that I should have been able to just let... Well, R is 1, S is 4. No. T is 36. 1 and 30 is 36. R equals S equals 1. Yeah, didn't we try that and conclude it didn't work? I guess, no, we tried R equals 1 and... Oh, okay, maybe we just clowned. I thought we I think I might have started with R equals 2, sorry. Okay, we tried with R equals 2, and then... Oh my god. Terrible damage. But I feel like the weights aren't... still don't match up. Or maybe they're just weak. Maybe the bounds are just weak. R is... So 1 plus cube root of 4... Oh, so it's equivalent to doing this and then also using AMGM on these individual weights. That's what it's equivalent to doing. So the claim is that 1, 1, and like whatever makes this... Nine, I guess. Yeah. Wait, is it 36 or 9? No, 36. Yeah, so it's equivalent to say RST equals 1, 136 works. Okay, well, that... Alright, well, okay, so I rest my case that the problem was what I thought it was, and the only issue was computing the weights by hand. And apparently the correct weights are 1, 136 because then you can use AMGM. Yeah. Yeah, pick a random RST. Okay. Now we're doing the block problem, I guess. Am I adding this problem into my database? I feel like this problem is so like contrived that I'm a little reluctant to add it, but whatever. As long as I wrote the flipping up, I guess might as well. Ta-da. More blunt. Oh, this wasn't okay. More blunt approaches exist by simply randomly guessing, say. Oops. I think this should all be under a marked environment. Or but alright. Ta-da. Oh, the glare on that is really bad today. Whatever. Oh, right. I have to attribute the author. Okay. Alright, let's move on to the other problem. Yeah, I'm glad that actually worked. I felt like that because the inequality looks so weak, there wasn't a way that I was going to end up not solving it by some sort of very forceful methods. That's why I went and ran after it first, because I don't think this cube's problem is going to be very fast. So, when it says aligned, does it just mean axis aligned? Or is it like... Presumably it means just axis aligned, right? And then that's all you can say. Stated the problem is still open. Wow, that is not encouraging. I really get the short end of the stick with some of these proposals. Like, I'm not opposed to trying open problems. I just think that the educational value may not be very high because it will mostly be me running around in a circle. Okay, wait. When you say for odd 2 n plus 1, is n like the thing? I think there's 2 n's. Is n now the side of the cube, or is it like sec k? So you want? All right. Okay. So show that at most. Okay. Half n plus 1, 2n plus 1. Axis align blocks with dimensions placed in a 2n by 2n. Okay, hopefully that's a correct statement. Oh, speaking of which, as I pull up the whiteboard, if any of you are curious from was on my qualifying exams, we did the qualifying exams over Zoom, and then I just pulled up the same whiteboard, and I was just too lazy to change it to the non-Twitch whiteboard. So for about the next few moments, the Twitch board will have the content of my qualifying exams, which was a disaster. However, I'm surely going to take it down because I'm not sure the examiners would appreciate.
Are you sure you're okay, Ward?
Oh, come on. Color 2 by 2 by 2 cubes with 2 colors. Oh, are you kidding? It's... So you want to say Now I'm less happy because that means it's like there was a clean argument and it got something that was slightly off, and now I need to optimize the argument, which seems like it may not be so easy. Okay, let me clear out the board. Each of the planes has an empty cell. Alright. Okay. When is test review? Oh, right. I did that last year. Do people want TST review? I guess people always want stuff. I have to teach on Monday though, is the problem. Yeah. Does your announcement mean you passed quals? Yes. Yeah. What I've learned is that apparently, like, even if you don't know the answers to half the questions they ask, they'll still pass you anyways. That's what I found out. Like, they really were not kidding when they said, like, most people just pass. They literally asked me things like, can you define, like, so-and-so? Like, can you recall the definition of an object? And I didn't know what the definition was. I was just like, this is not even close. Passed the qualify. Yeah, so I now officially have an advisor. I am officially Way's kid. Okay. Who is Wei? Wei Zhang is he's a professor in number theory at MIT. He's probably like one of the nicest professors in the department. And he does very technical stuff. So I signed up for the expertly technical. I.e. not compo. Alright, let's get the show on the road. Oh, actually, before I do that, I will make the update. I don't know if does he have a website? Okay, that'll be in the next update. I don't know if I can run it from this side because I don't have the key. Right. The proof is way easier. Okay, so you're okay. Alright, let's go. Okay, so welcome back. We have here a problem that's apparently from a paper, and it's open whether this bound is tight, but you have n congruent to 1 over 2 mod 4. And small n. Alright, n is congruent to 1 over 2 mod 4. You have an n by n cube. And you have these 1 by 2 by 4 blocks. So they look like that. 1 by 2 by 4. And there's if you do a standard coloring, global, etc. argument, then you should be able to show what? I missed what the thing was. I guess if you checkerboard color it, then there's more odd things than even things by some number, by 1. How far is this from 2n plus 1 cubed? Minus 1 over... Okay, wait. First so the claim was, first of all, this bound holds without the minus 1 for all n. And I'm trying to like reconstruct why that is, because that is not even the current problem, that's like before it. So... on every plane, you have like a 2n plus 1 squared, and you're taking out even sized chunks. So there's a missing square in every plane, and if that gives you a sum bound. Is that equal to the given expression? Let's hope it is. Yes, it is. Okay, we're saved. Okay. Okay, fine. So basically in every plane, so like any 2n plus 1 by 2n plus 1 by 1 cross section, there's at least one missing cell, and if you do that, right away you get the bound without the minus 1. And I want to show that if n is 1 over 2 mod 4, then that bound is not sharp. You can never achieve exactly that thing. I feel like this feels like it wants to be global. Right? It's something like So assume for a contradiction you got exactly this, then the sum across all the, what do you call a 1 by 2 by 4 block? Is that like is there a word for 1 by 2 by 4 block? We'll call it a tray, alright? Because it looks like an ice cube tray, although I guess those are more like 12. The sum across trays of x plus y plus z should be exactly equal to the sum of... It's like this. Right? Because in order for equality to hold, you must be missing exactly one. The missing cells, the 2n plus 1 missing cells. This should be 2n plus 1, not n. The 2n plus 1 missing cells ought to form like a transversal thing Yeah, it's like there's one of each coordinate exactly once. Yeah, ice tray. Alright, so this is some blob. I don't know what this looks like. Alright, factor and compute. So 2n plus 1 times n plus 1 times 1 plus da 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 plus 2n plus 1 all squared minus 3. On the other hand, in an ice tray, you have something like s plus 1, s plus 1, s plus 2, s plus 2, s plus 3. For the sum of the coordinates, it looks like this. So this is a total sum of 8s plus 10, 16. So I guess this is divisible by 8? Or something like that? Okay, so the question is, what is this divisible by 8? If n is 0 or 1 mod 4, then this thing is 1 or 2 mod 4. So it has a most one factor of 2. This thing is just odd. I should do these in green, actually. This thing is just odd. And this freaking monstrosity is equal to... Well, okay, it's a square minus 3. So I don't even care what's in the square. Like, this will have a most one factor of 2. Squares are 0, 1, so this is 1 or 2 mod 4. So... Is that it? I think that's just it, right? Like, I feel like the n equals 1 or 2 mod 4 part is so... The global argument should kill off some residue classes n. Like, I feel like it was no chance that it didn't kill anything. So... Ditto. Alright, cool. Alright, so I actually guessed wrong and this took less time than the inequality. That's neater than the papers? Go me. Alright, that's actually... Okay, this is actually a good problem for a stream. I was worried when you told me it was open, because I was just going to be like, oh, jeez. Does this work for n is 0 mod 4? Probably. Yeah, it also works for n is 0 mod 4. So then, if n is 3 mod 4... Is there an example where it hits... Now I'm curious whether, like... What the heck are... Did I screw up the expression? Hang on, I think, yeah, I definitely screwed up the expression. Hang on, Oh crap, I was wondering why this seemed too good. Is this like 3 times 2n plus 1 squared? For the whole thing? I think so, right? Okay, so then life is less good. 3 factors out. Okay, so this part is the same. The difference is that in here is this minus 1. Okay, maybe I... Alright, it was worth a shot. 2n plus 1 squared minus 1, which might be... Oh crap. Okay, so now I have to worry a little. I want that to not be divisible by 4. Shit. I guess it is 4n squared plus 4n. So that's okay. Wait, no, wait. We definitely just died then, right? This doesn't kill anything. Because that thing is very even. That bound didn't get the -1. I feel like there should be an 8. Maybe there isn't. I thought that there should be some residue clause for which this shows that it doesn't go through. Oh no. Alright, crap. No, that's not good. Well, it's n is 1 and 2 mod 4, right? So those are the cases for which the v2 is bounded. So this is exactly a factor of 4. Is n plus 1 a double root of this, really? All right, well said. Yeah, that's all the factors are too. I guess maybe it's not surprising because we did use a parity argument once to get the bound to begin with, so maybe I shouldn't expect there's another parity obstruction. But I feel like we used only the facts in the original thing that there was an even number of blocks inside each plane. So I thought like the additional mod 8 information should tell me something. But the problem is when you apparently when you delete the missing cells, you get a ton of factors of 2. So what's up with that? I feel like I really want to look at the sum because I don't know exactly what the transversal is, right? Like there's n missing cells, no two in the same like x or y or z coordinate. But if I don't look at the sum, then there isn't really. I would have to like solve the problem for multiple choices of transversal, which seems pretty not good. Like I want it should be some sort of global sum. But it's not just mod A. Okay, alright, we're gonna do the nuclear option, which is called we're gonna write out the polynomial now. I thought it would just die to a parity coloring, but it didn't, so we're gonna go full nuclear in terms of the coloring argument. And this time we're gonna compute the sum over ice trays of the generating function x to the I guess I should change letters since we're doing it this way. So on the one hand, this is the generating function of the whole thing, which is x to the 2n plus 2 minus 1 over x minus 1 minus like the sum of transversal. So some transversal, which I don't really understand. On the other hand, this should be equal to a sum of combinations of so it's like in the ideal spanned by 1 plus x, 1 plus y squared plus y cubed, and the cyclic variance. So there's like 6 different ways you can span. So now I would like to specialize. If I specialize x, y, and z to be like I. Does anything happen? Well, then the left hand side is 0. What is the right hand side? It's like this thing is equal to 1 plus x to the 2n minus 2. We're told that n is 0. We're in the 1 mod or 2 mod 4 case. So I don't know what that means here. Okay, I'm just gonna let x equals y equals z equals y and see what happens. We're gonna do the dumb thing first, and it's probably not gonna work, and then we'll figure out. But it'll at least give us a sense of what we should be trying. So if I do this, then the sum of the ice trays is 0. Because each ice tray vanishes. And the sum on the right hand side okay, so this a plus b plus c thing is actually not that good. It tells us basically what the product is, and that's about it. On the other hand, I have no idea what I'm doing. So, okay, let's say n is 1 mod 4. then this thing should be 2n. Okay, so 2n minus 2 is then a multiple of 4. So this should be I cubed, which is minus I. And then I have like 2n plus 1 terms here, doing so and so thing. Oh my lord. This was a mistake. You know what? Screw it. We're gonna take the. I'm not gonna specialize yet. I think what I really want to do is I'm taking modulo a certain ideal, right? So I'm taking modulo the restraint that like this ideal is 0, which should let me clean up this product like heck, because so modulo I, on the one hand I get 0 here, on the other hand I get oh frick, this case is okay. So if n is 1 mod 4, then I can take like a 1 plus x times generic factor something for blows up something something. Those are all 1. Okay, wait. I need to split this. Okay. Screw it. Okay, so this is the constant term, and then after that I have like 1 plus x times x plus x cubed plus x to the 2n minus 1, and then in here the z stuff mostly dies. So this is like 1, and this is like also 1. Alright. If this is an n114 case. And then here I can also wipe out a bunch of stuff similarly. So this is like this better work. Yeah, so this is just oh my lord. Alright, so conclusion is that something was something. The sum over the transversal after my long beautiful calculations. This thing is equivalent to 1 plus sum I x to the I plus y to the I plus z to the I for I from 1 to 2n minus 2 modulo this convoluted ideal that I've defined. Yeah. Yeah, because basically it's like whenever this sort of thing happens, like, I mean, I don't think it's wrong to try coloring. I did too because I thought I could shoot it down. But they're sort of like, the polynomials are sort of the most general thing. Like, every coloring can be interpreted as a polynomial, but not every polynomial argument can be interpreted via coloring. So, anyways, for n mod 4, if n is 1 mod 4, we have this where I is the ideal generated by the trace. So it's like some yada yada. And there are indeed 2n minus 1 terms on each side, so I can't just take x equals y plus equals 1. However, can I take x just x? If I set all three variables equal and interpret this as an identity of polynomials, then what do I get? I get like the sum over the transversal of x to the a plus b plus c is congruent to 1 plus the sum mod some crap 1 plus x and 1 plus x squared plus x cubed. And by the Chinese remainder theorem, oh. I might know what to do with this. So you get that. And what I'm going to do is plugging in x equals 1 isn't good enough. But the best thing I can plug in is the roots. By Chinese remainder theorem, I plug in x equals minus 1 and x equals 1. X equals 1 seems to seemingly not do anything until minus 1 seems like it shouldn't do anything until, oh frick. Wait, what are the roots of this? I and minus I. Evan, don't overcomplicate. We're already going down this path. So 1 plus x squared divides is x equals minus 1 is a double root of this is transversal. And now that implies by differentiation that 1 plus x is a root of sum I x minus 1, 1, 2n minus 2 minus the sum transversal a plus b plus c x to the a plus b plus c minus 1. That might not actually work. Oh, frick. I thought I was plugging in x equals minus plus 1, which would have worked a lot better. Damn it. Did I just plug in minus 1 here? Is there any chance that works? If I just plug in minus 1 before differentiating, what does the parity look like? Mod... No, that's even worse, because it's true mod 2, so like... I don't know. How about I just plug minus 1 into both of these and see what happens? So minus 1 here. This thing kills itself. So 1 equals the sum of minus 1 to the a plus b plus c. Here, when I plug in minus 1, this thing does not die. It becomes some thingy-mablubber. I'm not sure exactly what. Um, Three times n minus 1 is equal to like a plus b plus c minus 1 to the a plus b plus c. I hope. Let me double check that. I think so. Yeah, I think that's really correct. So the question is, can these two equations be compatible where a, b, c go over a transversal? So each of a, b, c is 1 through n exactly once. I don't know. Maybe? What happens if I just take him out too? No, it doesn't do anything, because number of transversals is 2 n minus 1. So taking this equation actually gives me the top equation actually gives me no information when I take him out too. And I need to... Oh my god. The top equation tells me there's exactly n plus 1 transversals whose like base cell is on something of odd sum and then something similar for even. So like it's pretty equally distributed. I don't think that will help me a lot. The other thing I haven't tried that I could do is I could plug in x equals a fourth root of unity, and that might tell me something. I don't think it should though. If I plug in a fourth root of unity, the equation instead says what? Adding both mod 2. Well, these equations I got assuming n is 1 mod 4. Wait, what? Adding kills it? No way. Yeah, these are the 1 mod 4 equations. Do they actually work? I thought they didn't work. Just... What I was going to do is I was going to say like, when I look at the first equation, it tells me that hang on. I think the parity doesn't check out, right? Adding gives 3n minus 2 is even. Am I a crazy person? Why is it even? Okay. But here, this one should do something. So this says it's not just mod 2. I have exactly n plus 1 things which have a plus b plus c even, and exactly n which have it odd. Then when I plug in a fourth root of unity, I get this thing. But I know that they split into n plus 1 things. This is all with n1 mod 4. Yeah, it's like the wrong number of... Wait. Wait, is this just false? I feel like this doesn't work mod 2, like mod 2 and 0. One moment. This feels a little too good to be true. I might have messed something up. That thing vanishes, and then... I feel like the blue equation alone doesn't feel like it should be true. Am I wrong? You have n things in the transversal. N is 1 mod 4. Okay, dude, no, I might need the thing. But the problem is this thing doesn't match. Because it means the number of things for which this is real is an even number. So you'll never get an odd 1. Is that it? Does that work? I think this should just work. Alright, I really hope this is right, because it's really hard to debug. Alright, so we're gonna move on. And I'm gonna do the same thing for n is 2 mod 4. When n is 2 mod 4... So again, I need to calculate what, like, 1 plus x to the 2n minus 2 is times the symmetric things. So I guess because I only ended up taking, like, x equals plus minus I, I don't know. Whatever. I see no reason not to. So when it's that, okay, so modulo the same ideal we've been using. You know what? Screw this. Well, we're just gonna let x equals y equals z, because I don't think we will need all 3 variables. It's so annoying. So, it's if I replicate the same thing, yeah, you still have the sum of transversal, and also the base thing, and okay. So the sum of the transversal is apparently congruent to this thing, mod 1 plus x plus x squared plus x cubed. And last time all we did was we plugged in minus 1 and minus I. And it worked because I guess when you plug in minus 1, it's definitely equal to 1. When you plug in minus I, in the 1 mod 4 case, it's also equal to 1, I think. Because 2n minus 2, the number of terms is 2n minus 1. So n is 1 mod 4. It's like you have the 1 and then things are multiple 4. Here, 2n minus 2 is now 2 mod 4. So after the first 2 terms, everything vanishes. So this is 1 plus x cubed mod the same thing. Okay, so then we will do the same thing, which is plug in minus 1 and plug in I and pray. So when I plug in x equals minus 1, I have an equality where this is still 0. So again, there's n plus 1 even things in the transversal and n things odd. when I plug in I this time, I do not get 1 and sorry, this is. Wait, did I screw something up earlier? Sorry, this is -1. Alright, -1. Oh, this is actually 0 this time. Wait, what? How's that even possible? Is this just die mod 2? No way. No, we checked that it doesn't work mod 2. Huh? Wait, didn't we check this, what? Hang on, what? Okay, that means I screwed something up. Probably at the step where I took modulo, Oh, the 1 plus x cubed might be borked. Did I bork the thing earlier? I don't think I borked the earlier one, though. Okay, you know what? We're just going to leave that expression as is. I'm not even going to try to take him out the polynomial. Because if this case ends up being similar to the other case, then I should just be able to plug in the values themselves. When I plug in -1, there's 2n minus 1 terms here. And so this will be exactly 1. So same conclusion. There's n plus 1 even, n plus 1 minus 1 odd. When I plug in I, so this is minus I. I think. Yeah, okay. Why n is 1 and 2 mod 4? Wait, but is this not gonna work? I feel like this should just kind of run it over. We'll see. So here, because n is 1 mod 4, n is 2 mod 4, so this is an odd number. Yeah, so this is fine, right? This just works, because now... Okay, please tell me I got it this time. I think this is... So you have the wrong parity of the number of things that you want to have be imaginary. And this is why you always use the... If the coloring doesn't work, just switch to the polynomial. It's always better. Basically. Does that work? The point is that the original bound is odd for these n. Wait, it is? Oh, it is. Does that matter though? Because the... Like, we tried to do it with just v2 earlier and it like flopped on us, right? When I did that thing with 8s plus 16. Well, I like... I don't know. That matters. You get a contradiction soon. Okay. I don't know. I'm sticking to my guns. This was actually too general. I overestimated the problem and thought it would be really scary and I would need all the variables. But you only need to plug in the 2 values. So you just need to plug in x equals I and x equals -1. And also, you don't need 3 different variables. Just x equals y equals z is sufficient. So the proof for n is 1 mod 4 looks way longer than it needs to be. It's because I took the max. It's easier to like take a maximally general setup and then specialize it to as you find out what's going on, then like start with the specific setup and get a general one. Thank you Core314 and Nihilate for the follow. Welcome to Evan's math stream. Alright, so, but yeah, this should work, right? Prepare to mess up again. Alright. I don't know if I might. I don't know. Okay, I'm gonna do the write-up, and it should be a lot less bad than I made it look, because now I know that I only need a few values. Okay. I don't even need the... In every plane, there is... section, an ice tray intersects. Any ice tray intersects roll section and even number of cells. This should say 2n plus 1. Okay, so this gives you a balance of 2n plus 1 cubed over a... I'm gonna keep writing n where I mean 2n plus 1. Okay, assume for contradiction there is inequality case above. And let impose coordinates 0, 1 to 2n minus 2n cubed. I feel like I had 2n minus 1s, which might be not great. We'll find out soon. Okay. The equality case above. Okay. Then we have a generate. Sum of x to 0, x plus 1. Because the cube was partitioned into ice trays, it follows that it's divisible by 1 plus x, 1 plus... Particular. Okay, so f of I is equal to 0 is equal to... Okay, so when n is 1 mod 4, it's x0, x to the... I definitely discomputed something, but we're gonna pray that this solution still works. So n is 1 mod 4, this sum is 2 mod 4. This might not work. F of minus 1. What did I do wrong on the board? Is it because I got confused with the difference between like n and 2 and minus 1 or something? This is bad because it doesn't depend on the... It's not really using n mod 4, I think. It's almost just using n mod 2, this argument. Nets. Okay. All right. So how screwed are we? First of all, what's the value of 1 plus I cubed? Does anyone know? Because I don't know off my head. I guess, okay, so 2 plus 2i, I guess? That seems like it's just, like, straight up impossible. Since the number of... What am I doing? Why are all my calculations giving different things? Ooh, that's what happens when you get old. No, that generating function has 2n minus 1 terms, right? If it has 2n minus 1 terms, then this is just 1. Yeah, okay, that's what we had before. But then second equation is not possible because the imaginary component okay, similarly if n is 2 mod 4 yada yada, that sum is still 1, but this sum is 2n minus 1, so this is 3, so it's minus I cubed, which is I. Okay, so that's it. The mod 4 comes in to what depending on what this thing equals. So this generating function, I over-prepared. I had x, y, and z. You don't need that many, just do that. Alright, cool. Right, and this is apparently from the paper, question mark. I don't have the 1, x2, x4 packing, and then this is some mathematician's paper. Grid, genfunc, polynomial, global, parity, utility case. Alright, we did it. Oh, yeah, okay. Oh, amazing. My dad joined my Discord server. Well, we'll see how that goes. Okay. Alright. Do I want to do another problem or should I just go sleep? Or am I pretty burnt? Are people still watching? Let me first figure that out. Not really. We got in 2 problems, which is not terrible. Both of them took a while. I don't know if any of these are things I can get quickly though. Earth to chat. Who is here? How do I see who is here? There's the button that lets me do that somewhere, right? Okay. Thank you, 2B, 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 2B. Hang on. 2B, 2B, 2BB, 22B2 for the follow. Yeah, I had my qualifying exams today. At MIT, it's supposed to be a formality. Like, no one really is supposed to fail their quals. But I was still freaking out anyways because I didn't know anything. And then I took the quals, which was an oral exam, and didn't know, like, half the questions. There were literally questions that were just like, can you define an automorphic representation? Which is, like, you know, my major topic. And I got the definition wrong. It's just like, stuff like this over and over. And then they let me pass anyways, because, I don't know. I guess maybe they felt bad for me. So... Yeah, I think I concluded that I probably over-prepared, because apparently I could have done anything and probably still passed. Maybe. I probably shouldn't jinx it. I'm just like, oh, I didn't die. That was the problem. It was fine. Yeah. It was doable. It was sort of what I expected of if it had been an Olympiad problem. I was just scared initially because if it's a paper kind of result, that's not the kind of thing I can get quickly on a stream. But the natural first thing to try works, so whoop-de-doo. Yeah, I read the combinatorial solution. I don't know. I just feel like anytime the solution is like of this global shape, like I'm always going to take the generating function because it'll just subsume whatever global arguments you could do by hand. Or something like that. Do you solve programs using programming? Occasionally for certain egregious problems, I will whip out Python. I try to avoid it because this is supposed to be a Math Olympiad stream, and I want to try to do the problems under like remotely comparable conditions, but sometimes if I'm annoyed, I will just program it. And you can probably find some of those on YouTube. I want to do one more that's quick, but none of these look quick is the problem. Like the IMO 1999 one doesn't look that fast either. Maybe? Is it actually easy? Okay. I guess I should try the IMO one because it's an IMO one and it's probably not too annoying. We'll find out. Hi, Nuke. Why not 1996? Do you think the 1996 will be... It's an FE! Okay, fine, we'll do the FE. I am not an FE person. But you already knew that, didn't you? Alright, so, I guess we're doing a functional equation. I don't know why these... Alright, FE, so find all functions such that thing is true. Yeah. Alright, so first of all, FF... XFY... Wait, what? There's an XFY term, so it's not linear. Like, the answer is not linear functions. Oh my god. I don't want to do this. Okay. Alright, we're just gonna... I'm gonna plug some random stuff in first because I don't even know what the solution set is and I don't want to agonize too much. I want to have a foothold that I can... So FFY. So if I let x equals fy, then the following identity is true, which strongly suggests the answer is like of the form f of something is it like square plus 1 or plus 1n square? I can't tell. Wait, is this a 2015 A2? It's not quite, right? But anyways, alright. So, okay, if it's plus 1, that doesn't... Wait, the coefficients don't even look right. No, it's not like a square. It's like... If f was going to be a polynomial, which I assume it probably is, what polynomial makes this true? The leading coefficient is c squared plus... Wait, did I plug this in wrong? This is really sketch. Fy... FFY, FY, Okay, if the leading coefficient is C, then this leading coefficient here is... Oh my god, I hate this. If you want to figure out how to make viewers think that Math Olympiads is boring, just give them a functional equation. Which is literally, there was a year where like number 1 was an FE and I forget what, it was either Mind Your Decisions or something else, like, where it's like, this is what Math Olympiads are like, and I'm like, why did you pick this problem? Of all the problems you could have picked, why did you pick the most boring functional equation I've ever seen? But here we are. Like, not all of them are bad, but like, that particular one was just like, it was 2019 one, which is literally like, why? Like, most of your viewers can't even understand what the problem is saying anyways. Okay, sorry, let's do another round. So c to the n plus 1, so n is 2, and c squared is supposed to be equal c cubed. So, no. It's c squared c to the n plus 1 times 2 plus c squared is equal to 0. Where n is 2, so c... So, I need like c is minus 2? Oh my god, I don't like where this is going at all. Okay, so f of y is minus 2y squared plus some garbage. Alright, what is the constant term supposed to be? I don't want to know. F of 0 squared. What is the equal sign? It's asimp. Backslash asimp. As an asymptotic. Alright, meat grinder. Meat grinder. If f of y was equal to minus 2y squared plus kx plus l, then we want l to equal oh my god, this is so gross. Is there like not a way I can figure out what... Let's do the zero term first, okay? L is supposed to be L squared plus 2 f of L, which is like minus 2L squared plus KL minus 1, which is, I guess, a thing that can happen. And then something else is something... Oh my lord. Can someone just guess the pair K comma L? Because I really don't want to do this. Or I can compare the cubic order term. The cubic term is, so... minus 4... K plus 2f 2x squared plus kx plus l. Is 98.6 and more? Probably, but the viewer... There's just... So, there's one viewer, who keeps requesting the IMO problems just in reverse chronological order. I've probably done the 1998 one though, actually, now that I think about it. Yeah, I've done the 1998 one. I agree it's more fun, because this just seems like pain. Okay, so if I... So... Minus... Jesus Christ. Wait, I think it just... Wait, I can't tell. Okay, I think I concluded that k equals 0. Which makes it a lot easier to find L. Because I feel like this thing, like FFY versus FY squared has cubic term like 4k, and FFY has like twice that plus like an extra factor of minus 2. So comparing cubic term I think gives k equals 0, and comparing the constant term gives some garbage that I never want to look at. Okay, someone tell me what the solution is. This implies 3L squared minus L plus 1 equals 0. Does that even have a solution? That is a negative discriminant, right? So I probably screwed up. YC equals 2. Oh, shoot. Oh, crap. Yes. I agree it should be minus a half. Which means that I get to redo this. Okay. I think the cubic term should still give. So the cubic term is something here, and then this cubic term is 2 times my oh. So the cubic term now gives nothing. I regret my life. Okay, well, we're going to be a dirty cheater. So if f is a cubic of this oh, actually, that's not even true. I was going to say if f has a root, then when I plug in that root, it should cause like a ton of stuff to cancel and imply f of 0 is minus 1. Okay, you know what? I'm going to postpone this calculation because I really don't want to do it. This is just pain. So I think philosophically, the way I want to think of this is if I fix a value of f of y, fix a value of y such that f of y is something. I don't care what it is. Then what it says is like f of x minus. I should use a different letter. R. F of x minus r is f some like x times some constant, namely r, plus f of x minus some constant. So this is why we think that it's probably almost certainly quadratic, because this is true. And in fact, this will imply that on wait, I feel like this should almost murder the problem. Because I can pick this. So f is quadratic on multiples of r, is what we learned. On multiples of other than 0, I guess. You think it has to be minus x squared over 2 plus 1? Thanks. I'll take your word for it. I think it probably there's not a family, and I just like really didn't want to expand because I was just like, this is so painful. This is the kind of thing where I would use a program because I'm like, I could do it by hand if I wanted to, but you know what? Screw it. I have a life. Wait, when you say it has to be 1 minus x squared over 2, do you mean like unconditionally or assuming it's a polynomial? Because if it's unconditional, maybe they should pay more attention to that. Okay, cool. So we're gonna... Cool. So this is a relation we have, and we also know f is quadratic on multiples of anything in the image. So So then I guess the question is, can I get it on, like, Q? What is the shape of the argument I want? So this is not a fully wrapped functional equation, because there's an x on the outside. That x is how I'm going to be able to, like, access anything of use. So it comes down to I need to be able to control what f of y is. Is anything here I have output that? What outputs can I control? The problem is f is not actually surjective, right? Because we think f of x is probably minus half x squared plus 1. Why did I ask you to do this? I don't know. Like, this is exactly the kind of problem for which I'm pretty sure when I see the solution, I'm gonna be like, oh, it's another one of these. Like, there will be nothing surprising, it's just you do a lot of work, and then after the work, you extract the answer that you could have guessed. So, anyways, what if I let x equals 2fy? So that'll get rid of that really annoying cross term with the 2fy squared plus f of y minus 1 equals 0. Oh hey, that's very funny. That's almost the same relation as before, right? Wait a minute. What? Oh, come on. Is this gonna... No, there's a 2 out here. Okay, I'm like, no, this can't work. This is not f of y squared, right? This should be f of y outer square. Alright, so those are the two things you can get by, like, So I want a relation between, like, the double def somehow. Yeah, do I know? I don't think I have anything about FA versus F2A right now, but I can try to get it, because that will be like a Christmas miracle if we can get it. I'm gonna comment this. Oh, well, no, we have this thing, right? Although this thing might just be No, I think this thing, if I let x be like r, that's the same thing as before. Can I get you know it for a equals fy. Oh, you're saying that I should think the other way and say if I have... Yeah, this is a relation between this and this. Maybe. But honestly, when I look at this, I want to prove surjective, like, or some sort of surjection type result. Because this thing is literally, if you can get something in the range, it tells you exactly the value. So actually, this thing here is not that informative, is it? Is it? This thing is actually almost a corollary-ish of this. So if I have something in the image... Oh, hang on, okay. So here's what we're going to say. I think we have to let S be the image. Let S equals the image of F. Or range, or whatever you want to call it. I think image is more clear because range is sometimes means codomain. So, now we know two facts. So, one is that for S in the image, we have f of S is equal to minus half S squared plus some constant, which is probably 1. I think if you put these, okay, fine, I'll write it as it is. F0 plus 1 over 2. And also for S and S, we have f of 2s is equal to 1 plus 1 minus 2s squared plus 1. And finally, we have for S and S, if I just pick y to be... Or the original equation says that f of x minus s is equal to minus half s squared plus half... We're just going to call this c, okay? This constant is stupid. We know f of y, actually, because it's... Oh my god, it's whatever it is, right? Times x plus f of x minus 1, and then plus minus a half s squared plus c squared plus c. Which we should probably clean up a little bit, I guess, because this is freaking mess. Yes, x minus r, thanks. It would be really nice if we could somehow get c equals 1. I don't know if we can, though. Not from what's written here. Okay, so it equals something like that, and I hope I got that right. That's definitely a plus in the center. Thank you, Sankaria, for the follow. Sorry we're doing like the most boring problem when you came in. Or at least I think this problem's probably gonna just be like blah, 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 blah. Okay, I'm just gonna call this blob here kappa because that's an accurate description of how I feel right now. Okay, so this is what we're at. We can compute f on s and 2s. Which by induction means we should be able to compute f on n times s, right? So we have... Jesus Christ, what is this? Why is this so messy? Aren't you plugging f of y equals s? Oh, shoot! I nested in an extra layer. Oh. That explains a lot. Yes. Okay, alright. Rewind, rewind. Oops. If I plug in 2s, does this just give the thing that we had before? I think so, right? What am I gonna call this 1 plus c, alright? I want to shift c by 1, so there's no c minus 1 here. Okay, so now our functional equation is a lot more humane. It looks like this, and also we know the values at s. 2s is, we have it, but technically it really follows from here. And then by induction, we should be able to compute the values at like basically every... So what does that do for me? So if I do straight induction, this should be true, right? N times s times x minus half n s squared, or n squared s squared, by iterating the, no, not n squared s squared. Hang on. S and S implies... Oh, that's true. Don't you get arithmetic sum? I mean, the way I'm getting this one is I'm just imagining you replace S with NS because ostensibly it should be this. It should just look like that. And then this, I should just go by induction. So what does it mean? That means if I have some X value that achieves S, and then I translate it a bunch, I can... Shouldn't there at least be an NS term? And NC. You can't do that because X changes, right? Oh, yeah, it should be NC. Yeah. Oh, does it change? Am I a crazy person? I guess it's just like, how could this not be the thing that comes out when you do induction? Okay, I'll write it out and make sure, see if I'm crazy. You're not plugging in. Oh, I'm stupid. Okay, alright, I better write it up. Okay, so X minus S. Alright. Okay, so when I sum this up, so n times sx minus 1/2 ns squared, and then some quadratic thing in S, which is like S choose 2 and choose 2s squared, and then plus nc. It does work out that way? That's what I thought. Help. What did I have before? I already forgot. Okay, whatever. At least this is a correct derivation. So, this is, without waving hands, this is what you get. And I forgot what I got before, but it better, if it's not equal to this, it's wrong, and if it's equal to this, then go me. Is this homework, teacher? Is it homework? No. If someone gives you this problem for homework, then you might consider dropping the class. Isn't it minus 1/2 ns squared? Yes, minus, yes. Ah, so it is minus n squared s squared, right? Then, because you can add. Okay, I think that's actually what I wrote before, but anyways, moving on. Alright. So I can translate on sets S. Can I get any statement of the shape, like, if S and S and T and S, then like there's some or something of that shape is an S? So this is the original equation. And I have like this thing is an s. So if t is in, but the thing is it has a dependence on x where I don't really want there to be a dependence. But all right. How do I mess with this to get two things? Yeah, I should hold for negative n, yeah. Bye. And so, if I know the value of f of n times s for every integer n, and I have a temptation to say, like, suppose f of x equals t, and then, like, compute, like, take a fixed value, like, or take a fixed, what do I call it? A fixed input and a fixed, suppose it has an output, like, little t, and that will let you compute f on any linear combination of s and t. Cyanide for dinner, what's up? Hi. Someone told me to do this problem. I don't know why, but now we're doing it, and I'm regretting my life decisions. That's about it. Alright, I'm just gonna... Oh, actually, here's what I want to do, alright? Suppose s in s... and t in t. What we're going to do is we're going to compute f of x plus s plus t, or f of x minus s minus t in two different ways. On the one hand, it's equal to f of x minus s minus f of t, which is known. Sorry. What am I saying? Plus tx minus s minus half s squared plus c. And on the other hand, it's equal to f of x minus t plus s times x minus t minus half t squared plus c. What about defining that? Maybe? Okay. I want to run this one more time and see what happens. We're gonna pray that we don't just get this something symmetric. F of x plus sx plus tx minus t. Oh, frick, it's symmetric. Are you kidding me? Yeah, or sorry, yeah, that should be S. Yeah, just I was trying to take two elements and compute this in two different ways and see if anything would happen. But it ended up not giving me a relation, which is sad. So that probably means if I do it even for like generic integer m and generic integer n, it won't give me a relation. Okay, I mean, if you do that substitution with G, the problem is the image of f is like some random thing now. But I think, I guess what will happen is like, it'll say g of x and g of x minus s differ by a constant. So g is like... Actually, that's not terrible. G is periodic. Can we... G is periodic. Wait, this is so weird. Oh no, this is weird. Okay, I think I want to try that G thing. So if g of x is f of x plus half x squared minus 1 plus f naught over 2, and then it's a constant coefficient I'm worried about. I don't know if the constant shift will quite do it. I think it just reads like this. So the function g is periodic-ish up to a linear shift. It's like g the function g minus like constant over s. This might at least give us a way to show c is 0, because it seems not believable that you could have a function that's periodic with two different periods and the growth rates are different. Although, wait, actually, we don't know anything about the function though, so who knows? How about you divide both sides by n's and to make it limit to 0? The problem is you don't know f is differentiable or even continuous, so you're not allowed to take a derivative. Or a limit. I agree, if f is the continuous or differentiable or whatever, then you can, I think you can just argue that s can be arbitrarily small and then run it over. But if you don't have a continuity hypothesis, all of that is pipe dream. Yeah. Can I at least show c equals 0? So that's all I want in life. So basically the problem comes down to this. We need to have enough values in S. Like you don't want S to be a small set. And the only place where we can get values like that, well, there's two things that could happen. One is that we try to use inequalities of some sort, which I'm reluctant to do because we don't really have any sort of non-negativity. And the other is that you need to use this x like heck. Like this value of x is what's going to make things in the domain. The problem is that it's like differences. So maybe what I should say is if S and S is given and not 0, I can pick an x such that I have two values which differ by like a given constant. I think. Maybe? So suppose I can find u and v such that u minus v is equal to some number that I have control over. I don't know what to call it, so we're just gonna call it z. Then I guess I now have to plug in u and v, right? So, alright. F of x plus v minus f of x plus s times x plus v minus half s squared plus c. And then I run the reverse relation. F of x plus v is some... Jesus, I hate this. Okay, so I need to flip a bunch of signs as I do this. F of x plus v should be equal to... oh wait, no, I have the induction result. Okay, so when I plug in -1, I get minus vx minus half s squared minus c. Where z is under our control now. So that's good news. So minus vx wait, sorry, there's no s. These should be u's. This is u. So the good news is the c's cancel out, so they go bye-bye. And the bad news is there's a bunch of garbage. But I guess it's a constant, right? Is the point? No, it's not constant. There's an x term, and that x term has coefficient z. So this is like... we're gonna call it gz, because we have no idea what it looks like. That is solving this problem. So, I don't know if that's a serious question or a joke question, but if you want a serious answer, I think most functional equations are written by just like taking a true identity and putting some f's on it until you get a good problem. Or by good, I mean like not terrible. I have it on a lot of people's word that this is how a lot of functional equations are made. Yeah, I'm not an FE person. I'm sorry. I don't understand it. Some of them I can understand because like the solution set isn't what you expect, and I find that like, oh, that's pretty surprising that this also works. I seriously, yeah, it's basically people stick f's on equations and then try to solve it. It's like the reason they're actually so popular is because they're actually the easiest kind of problem to create, to like mass produce. You just like stick some f's on some show identity and just run with it. Okay, so for any non-zero z in R, here's what's going on. For any non-zero z in real, we can find x such that, so a fixed and non-zero element of s which exists. Then by varying this blob over here, s times x, this is a linear thing in x, so you can make this anything. Then you can find x such that sx, well, we'll call this fixed element s naught just to emphasize that it doesn't vary. And I can find something such that this thing is equal to x. This means there are u and v such that u minus v is z and uv in R. Okay, so there is some real value function g of z such that this identity is true. And also if z equals 0, we can just vacuously assume we may, by setting g, we may as well allow z equals 0 as well. And now we have a new functional equation. F of x minus z minus f of x equals zx plus gz. Okay, so the bad news is we have a new functional equation. The good news is this functional equation is very easy. Because all the annoying stuff is gone. And like, you know, if you fix, I don't know. So to solve this functional equation, first I'll let x equals z, or to get the f of g of z is equal to f of z, or minus f of z, plus minus z squared plus f0. So now we have a new functional equation that says f of z plus z squared plus f of x minus z. Why does this not look right at all? Hang on, this is not satisfied by my... Oh no, it is, because it's a minus 1/2. Okay, so now we can do the thing that was suggested earlier, where let's let h of x be equal to half x squared plus f of x. And now the functional equation becomes something very simple. It's called h of z plus h of x minus z equals h of x plus h of 0. This means h is linear. Or sorry, this means h is additive. Alright, so now the function is additive, which is would have been good news, except I need to get some sort of bounded condition. However, oh shoot. Okay, so we blew the big part apart, and so this is our functional equation for S and S. And when I do the transformation suggested earlier, this is like h of x minus s minus h of x. What a mess. Alright, let's just roll it over. Now that it's additive, I feel like we should just be able to run the problem over, because we have the right substitution and the right black and additive, and so all I need is some sort of inequality constraint to prevent a bad Cauchy-like solution, and I should have that. So up until now, for S and S, so this is our basic facts. Blah blah blah. I don't care about this, and then, but we're going to rewrite this in terms of our. So again, let s equals image f, and h is half x squared plus f of x. So our functional equation now says for S and S you have all this crud goes away. Final line, should there be a z? Oh, yeah, that should be z, correct. Good eyes. So we have f of s. So we know h of s is given exactly by this constant. Does this work out to like, does the c go away? I don't think it does, right? Yeah. In particular, but in particular h is 0. Okay. That is, sorry, h is linear. Blah, blah, blah. We don't have, that's very sad. Sorry. H is a translate of an additive function. I don't think we get any more information. Wait, actually, okay. So the original functional equation, we boiled it down to something that looked a lot nicer. It's like, oh, now I'm worried. That means I need an inequality. So the original functional equation became that's weird. So original functional equation becomes this. If you rewrite it in terms of our h function, it should become this. I dropped some constant, but the constant is c. The problem is that constant is not C. I screwed something up. The problem is that this minus h of 0 h of x, this h of x minus s, because it's a translative and additive function, so because h of 0 is f of 0, which we decree to be, what did we decree f of 0 was? This constant is the most annoying thing ever. I just have to carry it around everywhere. Something's wrong. It should be C plus 1, that's fine. No, that's not fine. No, C is supposed to... We know that C is actually supposed to be... What? Wait, how much? Ah! They already... C... f of 0 is 1. So we think C is 0. Meaning f of... h of stuff should be 1. This is something... We think that this is actually the constant function whose value is... Okay, but h of 0 is f of 0, which is 2c plus 1. I must be crazy. These should all be C plus... Constants. The original equation says what? We think that h is a constant function, so this equation is just nonsensical. There's no way that's correct. Well, actually, no, we think it's correct as c equals 0. Problem is, we want h to be the constant function 1. This is also true. So maybe it's just okay, am I? Oh, okay, yeah. No, nothing broke, I think. So, no new information is what we learned. Congrats on passing your quals. Thank you. What I've learned is that you can like basically not know anything and still pass. Good shit. Okay, so h is a translative and additive function. And all we know about it is that okay, well, let's write what we have, alright? We now know at this point h of anything in S, by which a value of S is h of x minus a half x squared equals c plus 1 is what we know. And I guess because it's additive, I will break it into two parts. So the reason we don't really believe that it should be... So, okay. H is an additive function satisfying... So how do we derive this? All we did was plug in y equals s, right? But now that we know h is additive, these bits here don't give us anything new. So we just know h is a translate of an additive function. And we wish to show this implies... People like me feel bad. I don't know. I was freaking out about my calls for like multiple years because I was just like, I don't actually know any of this. And then the exam actually happened, and there were questions like, so my major topic was automorphic forms and representations. If you don't know what that means, don't find out. And like literally, like one of the exam questions was like, define an automorphic representation, and I couldn't get the definition right. And I'm like, maybe I should like know the definition of the thing that is my major topic. And yeah, the rest of the class was also similarly messy. And they let me pass anyways because apparently they're just nice. So anyways, so h is additive and satisfies... This implies h is constant. There's really no more data to get from the original functional, right? Because we have an additive thing, so this fx and ffy break apart. But we evaluated this, This is swallowed up by the quadratic thing. So yeah, we don't have... It boils down to this, and I feel weirded out. I don't know how to show that this is... Is it even true that this is constant? Wait, what is going on? Is this true? I almost don't think this is... no, but there's a square. This is so weird. I can't believe we still can't get the constancy. It's just been like hanging around the whole time, and I'm just like, I don't want to see you anymore. Get out of here. What a scam. I hate this. What is going on? It's gonna be something silly. I don't know what. Oh, I also forgot the translation factor for like the billionth time. H of 0 is 2c plus 1. But, Jesus, what am I supposed to do? Like, even if I knew the value of c, how do I show a function that satisfies this and is additive? Like, even if I knew the translation and that c was 0 somehow by black magic. What? It needs to have something to do with the fact that this is... I think I'm being scammed. Okay, here's what we're going to do. We're going to write h of 2x minus 2x squared equals c plus 1. And then h of x minus 2 times h of x minus x squared is also c plus 1. And then that means these two things have different 0, and now I'm going to abuse the additivity like heck. By which I mean when I subtract two things, it's a translative and additive function, so it's subtractive. New word, subtractive function. No, I can't. How does it go? So there's a factor of 2c plus 1. Shoot. Boss. You know, I should write what the condition is, alright? Translated. H0 is 2c plus 1. So subtract these and I will get something. What a mess. Okay, so now h of x squared is minus c. Okay, there. Alright, we got it on the positive reals. We did it. Yeah, okay. Oh my god. I don't know what I just did, but I did something. That's one for the Raptify unit. So, okay, I have to grudgingly admit that if I was a high school student, doing this problem probably would have increased my skill at functional equations. However, I'm not a high school student, so I'm just going to complain loudly about the fact that this problem exists. Also, I put it at like 50% chance that during the write-up I realized I messed something up. Okay, so for the other direction, let P of Fy, y we introduce the notation C is equal to F0 2 and S equals the image of F. Then F of S equals minus half S squared plus C plus 1. Is that a notation I used? I don't even know. No, I use F of 0 minus 1 over 2. The wiki solution is a dead portrait page. You can link it to my YouTube then. X minus S equals minus half S squared plus C plus. Claim. All right. Non-zero value S such that, and then choose X such that f of X minus S, or sorry, minus half S0 squared plus S X minus C equals Z. Then comparing Q x0 S and Q gives U equals x0 minus S and V equals. So this gives a pair UV where U minus Z is equal to V. Sorry, U minus V is equal to Z. And then I can copy that horrible calculation I did. Where X plus V, U, and equals minus okay, so this is actually the main claim. The main crowbar is you want to, because you can't control the X directly, what you do is you pick a single S0 and then force the difference to be Z and then compare these two. Okay, now let H of X equals half X squared plus fx, so H0 equals So h of x minus z is equal to h of x plus letting z x equals z in the above. So g of z is f of 0 plus
It's cold outside. Maybe someday you'll realize.
Okay, so now I should get okay, we're just gonna translate everything down. So h of 0 equals 0.
It's cold outside. Maybe someday you'll realize. It's cold outside. Maybe someday
Okay, so h is additive, beautiful. Thank you, WoodcraftX, for the follow. Welcome to the. Is this the only Math Olympiad stream? I actually don't know. It's not a very good spectator sport, honestly. But give the people what they want. All right, so elements of S are exactly this thing. Only one of the regular scenes traded. Okay, that's good to know. Okay, so bringing this all together, thus we derive. Okay, so minus c. Okay, so we're gonna first plug into x. And the other is we're gonna just multiply by x. Let's see. Okay, and then now subtraction. Yes. All right, so what I've learned is that if I'm gonna make a new function, I should always make it h0 equals 0, so I don't have to do that stupid juggling thing I had to do earlier with like floating constants everywhere that I couldn't keep track of. But anyways, h is equal to minus x squared minus 2c plus 1. All right, we did it. It's struggle. Yeah, that feels like that's an FE. Half fully wrapped. Work. Wow, some of these are so short. What did I miss? How did they get the difference? Oh, so this, okay, this is actually about the same as what I did. Wow, these are so much shorter than. Oh, whatever. This solution didn't have a trick. I think it's just, it's why I like don't like functional equations, because there's nothing special here. Right? It's just you do the things that you sort of expect, and grind it for a while, and then eventually it works out. And you know, maybe you get better at doing technical manipulations over time, but I don't know. Alright, we're done. Ah! Where's the other error? Oh, I thought I programmed it to remove the QED hues. Alright. 3 problems. Cool. Thanks everyone for coming by. We'll see you next time. Sleep time, yes, I agree. I have to grade TSTST tomorrow, so I need to actually not sleep until noon. Nah.